Hello, this is Chen, and here's my student ID. Today, I'm going to go over question 3A from homework 2, CSE 105. Let me share my screen. Okay, the reason why I picked this problem is I personally find it interesting to play around the formal constructions for DFA and NFA, but at the same time, it's also challenging to do so since we need to follow the constructions step by step and be careful with what we do. Otherwise, we're going to come up with wrong NFA. And a big part about this problem is understand how to apply the formal constructions, like the syntax and like the transition functions. So now let's take a look at 3A. 3A asks us to provide two DFAs, MB and MC, where MB has 2 states, MC has 3 states. And using this constraint and the construction above, we have to create a new NFA, M. And now let's take a look at the formal construction. So notice that here's a potential mistake that people might make. Notice that like normally when we create a DFA or NFA, we only have one component in our state. Let's say we only have Q0 or Q1. However, in our NFA in this case, we have to have 2 components, where the first component comes from MB and the second component comes from MC. This is because it requires that the states in our NFA should be in form of the Cartesian products of the states from MB and MC. So our NFA, our state in NFA should look like this. Also, here's another potential mistake that people might make, which is our NFA should have 6 states. 2 states from MB times 3 states from MC is 6 states for our NFA. So I noticed that a lot of people post questions on Piazza asking about what if they have some unreachable states in their NFA? Should they also include those states in their state diagram? And I think we should include all 6 states in our state diagram, just to show that we know there are 6 different states according to our formal construction. And even though there aren't any incoming arrows for those states, we still have to have them in our diagram. Okay, now let's go over my solution. So here I have 2 DFAs, whereas MB has 2 states and MC has 3 states. And here, based on these 2 DFA, I constructed this NFA, which has 6 different states. And each state is a Cartesian product of states from MB and MC. So now let's go over the transition function. Here it says upon reading at 0, MB as the first component in our Cartesian product should also process at 0 and go to the next state, whereas MC stays in the same state. So in this case, let's say if we're in Q0, when we read it 0, our MB should process at 0 and goes from Q0 to Q1, whereas MC, the state in MC states should stays the same, which in this case, we should go to Q1, Q0 when we read it 0, and we are in Q0, Q0. And this is indeed what we have. And the same idea can be applied when we read 1 and epsilon in our NFA. So this is the state diagram that I have, and these are all the work that I show here. I think that's pretty much it. Oh yeah, one more thing. We have to label Q0 as my start and accept state, because Q0 is the start and accept state in my MB, and Q0 is also the start and accept state in my MC. That's why Q0 is my start and accept state in my NFA. I think that's it. Thank you.